You have your notebook, textbook, everything. Keep it open. Is everyone paying attention? Virat, paying attention, right? So when we are talking about a bar magnet, and if it is broken into two pieces, each of the piece will have only north pole and south pole. What will it have? Again, it will have north pole and south pole. Okay. How do we know that it has got some kind of a field? What is that field which is called? It's a magnetic field. Okay. So we know that there is a magnetic field. Can you see the magnetic field? No. Can you see the extent of the magnetic field? Yes. Okay. Suppose I say this is a small safety pin or something of that sort. Maybe it's an iron nail. If I keep it very far away, what will happen? It will nothing. There won't be any attraction. But the moment I get the safety pin or an alpin or whatever, it is closer and closer. What's going to happen now? Immediately it will get attracted because of it. Correct? This is something that all of us have done. We played with magnets, so we know exactly what it is. Why does it happen? That's because there is a field which is present around the magnet, which is going to be affected. Is this field felt far away? Okay. If the distance is more, the magnetic field is stronger or weaker? Weaker. Isn't it? This magnetic field will be weaker. But as you're coming closer and closer, that means the distance has increased between the object and the magnet. Obviously, the strength of the magnetic field will be more. Is that clear? Okay. We're just going through all the properties of a bar magnet so that we can apply it when we talk about the other things which is coming to electric field. Right? Then, how do we know the direction or what is the pattern of the magnetic field? Can we do something about it? Can we do? Okay. So once again, we take some iron filings. What is filing? Iron dust. It is very small dust. So it is called as iron filing. Okay. So here what happens is we are going to sprinkle some iron filing, and then when you tap it, what happens? Basically, what happens is that you will find that this is going to arrange in some kind of a pattern. Don't you find that it arranges in this type of pattern? Probably you have seen this type of a pattern. Yes? Yes or no? Yes. If you're going far away, what is happening? These circles are becoming bigger and bigger. What does it mean? Does it tell us something about the effect of the magnetic field? Yes. Yes. So the magnetic field will be weaker as we go away from the magnet, and obviously the field strength will be more as we come closer to the magnet. Another thing, did you notice that wherever these lines are crowded, it shows that there is more magnetic field. So the strength of the magnetic field is more at the poles rather than the other poles. Is that okay here? This way is of course a very simple way by which we can find out the arrangement of the magnetic field lines. So what is a magnetic field? Is nothing but the force of the magnet and which is felt around it. Right? There's another method that which you can actually see. I have uploaded a video, but these people say that it is not visible. Maybe next time I'll be able to do it. Sorry. No. He was not able to do it. And we'll have to see. No, I believe it's a paid one or something of that sort. Who has done it? Okay, you have done it? No?
Yeah.
Okay, fine. We just see with it. Anyway, I'll see. The second method for us to find out this particular pattern is by once again using a small needle. Okay, what needle is this? It's a magnetic needle. Now just imagine that this is a magnetic needle. Most of you would have probably seen a small magnetic needle like that. Okay, and it is pivoted. Pivoted means what is a small, a small needle on which you have this magnetic needle which can move around. If you're ordinarily, imagine that this is a magnetic needle and you're suspending it with a thread and you're allowing it to move freely. In which direction will it show?
Point towards
Like
the
this, like this, like this. Which direction?
North, south.
Correct. North, south. Isn't it? So your magnetic needle is going to show in the north-south direction. Okay. Let us assume this black tip is your north and assume that that is the north. Okay. Is this the geographic north or is it the magnetic north?
Magnetic. Geography. Geography.
You are using a magnetic needle to tell you the direction, isn't it? So what does it tell us? If this is the north, it is showing the geographic north. But why is it pointing in this geographic north?
Because there is south pole.
Yes. Because there's a magnetic south which is there. Did you get it? How many of you did not understand? No, not yet. Okay, fine. I will. This is the earth.
And it's so strong. Yeah. The
And-
earth poles.
We are talking about the entire core which is molten. Okay. And we are not going too much into the details of your, okay, with the tilt and all that, 11 degrees, etc. All that we are saying is this is the north pole and this is the south pole. Okay. Now which north pole are we talking about? We are talking about the geographic north pole and this is the geographic south pole. So your Arctic is there and Antarctic is here. If you are able to understand that. Yes. Imagine that this is the equator of the sun. Now if I'm having a magnetic needle, this needle will point in the north-south direction. Why is the north of my magnetic needle pointing in this direction? Obviously there must be something there because we know that the light poles are repelling and the unlike poles are attracting. If the north of my needle is pointing in this direction, यहाँ magnetic क्या होगा? South pole. So your magnetic south is here. That's why my needle is going to be north. Did you all understand? Okay. So your magnetic north will be here. That's why my south pole is pointing here. Okay. Hello. Anybody? All of you have understood this concept? Very clear? Okay. So once again, coming back, we know that light poles are going to attract and light poles are going to repel and unlike poles are going to attract. Is that okay? Right. So whenever we are talking about this needle, magnetic needle, what is this? This itself is a small magnet. Okay, a magnetic needle, fine needle that we are talking to show us the directions. Thus, that itself is a magnet. And obviously it is getting aligned because of the magnetic effect of the earth itself. Okay, because when you see the core itself, that's nothing but a molten mass, and that is basically giving the magnetic north in the south. Is that okay? Yes. This is a compass, yes. This is a magnetic compass. This is a compass. Basically, you have written N and S, North Pole, South Pole, East, West. Okay, so this is how it is going to be, right? Is that okay? So the first part of the lesson, we are doing a thorough idea about the magnet and the magnetic needle, because when we are talking about the solenoid and etc., when we say it behaves exactly like a bar magnet, we must know the correlation. So look at the first activity. Okay, there's a first figure which is given there. What does it show? Yes, yes. Can you understand what the diagram is showing you?
Yes, ma'am.
Is it clear?
Yes, ma'am.
Okay. So what have we done? Let us assume that this is your cardboard, right? Look here. This is the cardboard, and we are making a hole here. We are passing the wire. Okay, passing the wire, and of course it is connected to the circuit. So what is there? You have got your battery, your ammeter is there, all those things are there. And we switch it on. Okay. Moment we switch it on, the current is passing. We know the direction of the current. If this is the positive and this is the negative, so the current will go in this direction. Okay. So when the wire is going through and the current is going passing through the wire, there's a magnetic field which is present around. There's something else which is kept on the cardboard. What is kept there? It's a small compass. So the moment you take the compass far away, it's showing in its north-south direction. But the moment you get it closer, what happens to the needle? The needle is showing the deflection. So with this, we can actually see what is the effect of the magnetic field. What will happen if you increase the strength of the current? Yes, what will happen? Will increase. The strength of the magnetic field will increase. The moment we are increasing the strength, that's a current. When you are increasing the strength of the current, obviously the strength of the magnetic field will also increase and it will show a greater deflection. So what can we understand by this? We can actually see the effect of the magnetic field which is present. Is that okay? Clear? Okay? Right. The other way of doing this is by, I told you, by putting iron filings. Okay, so the moment we put iron filings and tap it, obviously this is going to arrange in concentric circles. Right? What happens if I switch it off and I turn the terminals? अभी ये हो गया है not and that has become the positive pole and this has become the negative pole. So the current as a जाएगा. Okay, let us imagine the current is going like this. Will the deflection of your magnetic needle be in the same direction?
No.
Or will it be in the opposite direction? Very. So if you have understood this concept, it's very easy. Okay. So obviously when you are changing the direction of the current, there will be a change in the direction of the magnetic field also. Is that understood? Okay. See the person, scientist. Who is the scientist? Austin. Okay, so Austin, and so he is considered to be the father of electromagnetism, right? And therefore, we usually use Austin as the strength of the magnetic field. What is the next page? Magnetic field and field lines. Yeah? Yeah. So show that. Don't waste time. कमर मांग में जल्दी करें. इसी में डाला ना?
हम नीचे ही बुलाओ. अभी सर्च कर लेना.
वही नीचे ये डाउनलोड इधर नीचे नीचे अरे नीचे जा रहा है अरे तीन लाइन
अरे वो जो
ऊपर मेन्यू हाँ वहाँ होगा
अरे
भाई तू
अबे इतना बड़ा डाउनलोड चला.
No, it's not. I will show you. Don't worry.
अरे दूसरे चैनल में देख भाई यूट्यूब में देखते यूट्यूब को जो उधर
अरे भाई सर्च
नाम स्विच कर अरे इधर
This is the one.
भाई भाई अपलोड
Okay. Now this basically is telling us instead of having a straight wire, okay, instead of having a straight wire, what we have done is a coil of wire. Okay. This in fact I will be telling you a little later on. I will take it up a little later on because right now we have not come to the coil. Okay, we talk about the straight wire, understand about the right hand thumb rule, and then we'll go on to this part of it. Right? Okay, now magnetic field and field lines. Everybody in your textbook, right? We are familiar.
We are familiar with the fact that a compass needle
Yeah.
that a compass needle is reflected when brought near a bar magnet. Compass needle is in fact a small bar magnet. The
Underline this. What is it? It's a very fine, it is a very small bar magnet. Like,
The ends of the compass needle point approximately towards north and south direction. The end pointing towards north is called north seeking or north pole. The other end that points towards south is called south seeking or south pole. Through various activities, we have observed that like poles repel,
like pole repel.
like pole repel, while unlike poles of magnets attract each other.
Okay, there's an inbox in text question. Why does a compass needle get deflected when it is brought near a bar magnet? Sorry.
Because
See the question.
Because they are the same they are the same rules.
like same
No, that's because before it was according to the
Don't go to this. This is only for your
because
explanation.
now like the bar magnet has more magnetic.
My question, look at the question there. Why does a compass needle get deflected when it is brought near a bar magnet? This is a bar magnet and this is a needle. When you get it here, it is getting deflected. Why?
because
Because
of
of
Same
higher
pool.
magnetic
Some
magnetic charges. Right?
Because
Like charges.
Ma'am, because the compass is already pointing at the north pole.
Now this is a bar magnet. It is kept like
And
this.
like charges repels.
Or kuch bolo. What is there? That's all. Because the needle here, okay, the magnetic needle is getting influenced or it is coming under the influence of the magnetic field of the bar magnet. That's all. This is also a bar magnet. This is also a very fine bar magnet. Okay, because it comes under the influence of your magnetic field. That's why it shows a deflection.
मैम तो फिर
Okay, na?
अगर वो जो needle है
This is a needle. Assume that this is.
उसका point north में जा रहा है and जहाँ पे आप डाल
They are just talking about a deflection. Okay, maybe it is going this way, maybe.
मैम reflection तो तभी होगा ना like charges है
Suppose this is north and this is south. Okay, so obviously the north is going to come here. North of this needle will come towards the south of this.
like reflection
Otherwise, it is going to point in this direction because this is free to go around. It is still showing in the north-south direction. But the moment it comes under the influence of this bar magnet, obviously it will change direction. Do you understand? Now this, please listen. This is your needle. What needle? That's your magnetic needle. If it is allowed to be suspended, it is going to be showing your north-south direction. Okay, now I have kept this bar magnet on the table, right? When I get it closer, will it still point in the north-south direction? It will come under the influence of this. It's showing a deflection. That's it.
ये होता है मुझे लगा ऐसे point करें तो उल्टा
It's a deflection. There's a movement. That's all. Okay.
थोड़ा continue कीजिए
Yes. The iron filings.
the iron filings arrange themselves in a pattern as shown in figure 12.2. Why do the iron filings arrange in such a pattern? What does this pattern demonstrate? The magnet exerts its influence in the region surrounding it. Therefore, the iron filings experience a force. The force thus exerted makes iron filings to arrange in a pattern. The region surrounding a magnet in which the force of the magnet can be detected is said to have a magnetic field. The lines along which the iron filings align themselves represent magnetic field lines.
Okay. Did you underline? These are the important points that you should remember. Right? Iron filings experience a force. Now, which force are they talking about?
Magnetic.
It's obviously the magnetic force. Okay. The region around the magnet, underline from there, in which the force of the magnet can be detected is the magnetic field. right? The lines along which the iron filings align themselves are representing the magnetic field lines. Okay. Now let's also talk something about the direction of the magnetic field lines. Okay. We know that it has obviously magnitude and also direction. And always we find that it is from the north to the south. So from north to south. So is it a vector quantity or is it a scalar quantity? You remember what we learned in the 9th standard? Vector. You remember? Yes. Magme, 9th standard we have already learned. Vector has got direction and magnitude. Okay. A scalar will have only magnitude and direction.
Yes.
So magnetic field lines are vector. It's a vector quantity. Obviously, it is always from the north to the south. And you find any of these lines intersecting? No. It's always concentric circles. Okay. If at all these lines are intersecting, that means to say your magnetic needle will be pointing into different directions, which is not going to happen. So that's one of the characteristic features that you should remember, that the magnetic lines of force will never intersect. Okay, basically what is it showing? It is showing the direction. If it is intersecting, that means to say that it is showing two different directions, so it is not going to be further. So let's see what are the characteristic features of the magnetic lines of force. And you'll be writing it down because these are the important points. So I'm coming here. Okay. I was telling you about this part of it. Look at this activity. And it's also possible for us to plot this magnetic lines of force by using a magnetic needle. Right? Did you see the first one? See the first diagram? What have they done? They have taken basically a bar magnet like this. Okay. And you are going to keep a small magnetic needle, right? And you are going to note down the direction of your north. That's a needle. So when you are keeping it here, when you are keeping it here, when you are keeping it here in different positions, you will see that the north is pointing in this direction. This is the north. Here it is pointing in this direction. Here it may be pointing in this direction. This. Did you understand? Okay. So by plotting it, you are actually plotting the concentric lines of force. Did you get it? Okay. So that is how you are able to plot these lines here.
Yes, ma'am. Can you please repeat?
You are having a small needle. Okay, so that's your magnetic needle. By using a magnetic needle and keeping it in different positions and looking at the direction of the north, basically you can plot. Okay, so using a pencil, we can plot these points and then you can join it together, and that is how you can actually see the magnetic lines of force. Is that okay? Yeah. Okay. Don't sit under the fan. If you are feeling uncomfortable, just move. Okay. Now we are going to identify what are the characteristics. Pay attention, please. Somebody from this side, you would like to read? Magnetic field.
Magnetic field is a particular load direction and magnitude.
Underline, it has got both direction and magnitude. So what does it tell us? Direction and magnitude. Very good. Make a note of it in your textbook. Vector. Yeah. Vector. Yes, continue.
Direction of the magnetic field is taken to the direction in which north pole of the compass needle moves is. Therefore, it is
One
taken
minute,
by
one minute.
Therefore, it is taken by convention that the field line appears from north pole and merge at the south pole. Note the arrows marked on the field line in figure 12.2. Inside the magnet, the direction of the field line is from its south pole to its north pole. Thus, the magnetic field lines are closed curve. The relative strength of the magnetic field is shown by the degree of closeness of the field lines. The field is longer, that is, the force acting on the pole of another magnet place is greater than the field lines are curved.
Did you understand? When the field lines are crowded, that shows that the strength of the magnetic field will definitely more. Something about the direction of the magnetic field. What did they tell? In which direction? Suppose we have to plot and find out in which direction is it? From where to where?
North to
It's
south.
always from north to south. Okay, so we have got magnetic field lines from north to south. What happens inside the magnet?
South.
What happens
South to
inside the
south.
magnet? Yes, it is from south to north. Make a note of it. Did you understand? The statement is there. I don't know how many of you paid attention. Okay, the direction of the magnetic lines of force outside the magnet is from north to south, but it is inside the
South to
magnet. It is from south to north.
Why is it that?
Okay, it's a continuous line. No? It's a continuous line. Its line is not broken.
Acha, acha.
Inside, it is continuous. So these are closed continuous curves. Okay. Then the last line there, no two. Last line.
No two field lines are found to cross each other. If they did, it would mean that at the point of the intersection, the compass needle will point towards two directions, which is not possible.
Fine. Everybody in your notebook should answer. Okay. First question. Hurry up. Okay. What are the properties of magnetic field lines? What are the properties of magnetic field lines? You will refer to your textbook.
Yes.
Okay. Field line. Okay. What is the first point? 3 times I've already repeated, Kaushik. What are the properties of magnetic field lines? What is the first point? What is given in your textbook regarding direction and magnitude?
East or north.
Here.
It is the point that is more
It has vector quantity, right now. Okay, magnetic field lines are vector because it has both magnetic magnitude and direction.
Next one.
First point in your textbook. Okay. Second point, write about the direction.
direction. The ending point.
From where to where?
North to
North to south.
Come on, next point. Second point.
The magnetic field is
South to north inside the magnet.
First write down the direction of, I want the word direction. The direction of the magnetic field lines outside the magnet is from north to south. Is from north to south. But you continue in the same point. But inside the magnet,
The direction is south.
But inside the direction of the magnetic field is from south to north. क्या होगा inside the magnet क्या होगा बोलो
south to north.
अब उसके बाद magnetic field lines are
yes how can you find out the strength of a magnetic field? The closer the lines, the stronger will be the magnetic. Come on, write down. The magnetic field lines, next point. The magnetic field lines are closer at the poles. Yes, therefore, yeah. The magnetic field lines are closer at the poles. Therefore, it shows that magnetic field line is stronger. If the magnetic field lines are closer, it shows it's stronger. Magnetic field will be strong. Okay. Okay, got it, Umeda? Then the last point is the magnetic field lines. Yeah, do not intersect. What is wrong with you today? The last point you write, the magnetic field lines do not intersect. Very good. Okay, they do not intersect. If you turn the page, there is another set of questions on page number 200. Okay. Question number 3. What does it say? Yes, why don't they intersect each other? Will you be able to write? See what is written. See the last point. Yes, that is the answer there. Okay. If there are, listen to me, if these magnetic lines of force intersect, then it shows that there are two different directions, which is not going to be possible. So write down now. Take down the question. Question number 3. No two lines intersect with each other. Yeah. And write down the last one. No. Obviously no. If they did, it would mean that the point of intersection, it's there on page number 197, the last.
Question. What is the
The last line of 197.
If the lines intersect, did you get it?
Yes, please.
Right.
So like a 3-4 line explanation is fine.
Yeah. Show that it's from non-uniform, but they are not being simply because.
So we can draw like a small diagram.
If it is possible. Okay. There's another very important thing that I'd like to tell you. Children, look at the board. All of you, please look at the board. Put your pens down and listen very carefully. Sometimes you may have a diagrammatic question. It's a very simple thing like sketching out the magnetic lines of force, okay, around a bar magnet. Right? Leave it there. Okay. So what is very, very important? Suppose you have drawn the entire thing and you have not shown these arrows, you get a 0.
Because we have to show that.
Shh, listen, I didn't want an explanation. So very important for you to remember to draw these arrowheads and also to show the north and the south. Okay, if you have interchanged it, obviously the arrows will also change. If you understand, suppose I have drawn, either which way you can draw. I can put a north and the south in this direction. But if I am having a north here, this will be the direction. Always from north to south. Is that okay? So that's why in the examination, if a child has not shown these, or if you have not shown this, then there won't be any marks. Even though you have drawn the entire thing, there won't be any marks. So be careful about it. Make a note of it in your textbook.
We are going in the direction.
We don't know in which direction it is. North, south, and I know what is the direction. Okay. Make a note of it in the textbook so that when you read, you remember. It's there, no. How many times will I be on the video? Okay. Finished? Hurry up. Finished? We've already discussed regarding activity 12.5. Did you see activity 12.5? I've told you regarding how it creates this concentric lines of force. Okay, this diagram. Did you all see this diagram? I've already explained to you. Okay? Okay. Now, based on this, suppose this is a current carrying conductor, and let us say we have passed it through the cardboard like that, and we have put iron filings. Obviously, we have seen that these are concentric lines of force. Okay. Now, how do we know that it is in which direction it is? What did we say? That it is the direction of the north. But here there is no north south, but we know that there is some kind of a direction. Now that is where we come to right hand thumb rule. Did you see that? Right hand and thumb rule. So imagine that you are holding a current carrying conductor in your right hand. Don't get confused because there is a left hand rule also. But this is a thumb rule. And the thumb is pointing in the direction of the flow of current. Okay. Then your curled fingers will show you the direction of the magnetic field. I repeat. Imagine you are holding a current carrying conductor in your right hand such that the thumb points in the direction of the current. तो आपका यहाँ क्या आएगा? Positive current. यहाँ negative आएगा. So positive. Okay, that is how it is going. So such that the current is flowing in this direction. Then you have the curled fingers. These are fingers which are curled. These fingers will show you the direction of the magnetic field. This current is going in this direction. Suppose I reverse. I'm not talking about Fleming's. Listen to this. Don't get confused. Suppose I change the direction of the current, then the current will flow in this direction. Okay? Can I hold it like this? No. The thumb has to go in the direction of the current. So I will hold it like this. Current नीचे जा रहा है ना, तो we have to hold it this way. If the current is going in this direction, we hold it that way. Any which way. Suppose the current is going like this, I hold it like this. Suppose in the sum they have given you, because there are sums of this type, okay? They say the current is flowing from east to west. Okay, I'll be showing you this way so that you don't get confused. All of you will hold a pen or a pencil in your right hand. Right hand. Okay, okay. The nib part of it will be the direction of your current. Hold it like this. Okay, so the current is flowing here. If I change the direction, it will be like this. Got it? If the current is going in this direction, it is going to be like this. Or like this. Don't change the grip on your pen.
So this is the point.
I'm pressing
Okay. Now, okay. Right hand, okay. Right hand thumb rule. A convenient method, etc., etc. Page 199. Go on to page 200. Okay. I'm reading it very slowly so that you understand the words that you have to use. This is very, very important. Put a star or something of that sort. It's a short question. Page 200. What's wrong with you boys today? Shit. Imagine that you are holding a current carrying straight conductor. These are the words that we expect. If you miss out a single word, okay, in your right hand. Suppose a child has not written in the right hand, gone. Such that the thumb points in the direction of the current. Then your fingers will wrap around the conductor in the direction of the field lines of the magnetic field, and this is called as a right hand thumb rule. Okay, in yours, come on quickly. Hurry up, hurry up. State. State the right hand thumb rule. Right hand thumb rule. Imagine that you are holding a current carrying straight conductor in your right hand, carrying a current in your right hand, such that
I'm carrying.
And your right hand.
leave it. Leave whatever words you have missed out, leave it. Continue. Such that the thumb points the direction of the current. One might, I have told you it is there, I'm reading out from here. In spite of it, you are not understanding. Okay, continue. Then the curled fingers, or you can write whatever they have written in the book. You can also write down. Then the curled fingers will point in the direction of the magnetic field. This is your wire. Current is passing in this direction. Suppose I'm drawing a circuit diagram. Okay. Then there's an ammeter, there's a plug P, etc. etc. So you will get positive, this is what you're taking. The current will go in this direction. Everybody got it?
Yes, sir, in the lecture. Virat is saying that.
It's your library. Sorry to jump.
मैं कुछ बोला तो मुझे सब्जी नहीं मिला।
अरे पागल आता बीसी आता